Good morning, participants. Session will be starts within 5 minutes.
Okay. Okay. Is it okay? Am I audible?
Yes, sir.
Yeah. So yes, I'm checking if it's something. It's okay then. What's happening with this video? I don't know. Let me check. We don't have credentials for this, right? Or otherwise, I could have joined with the link directly. So this app is creating some problem in terms of what we call the scam. Uh, Let me try with another app. Just give me 1 minute time. Okay.
Okay.
Do you hear me? Yeah.
Yes, sir.
Yeah. So just I'm checking some little bit problem, facing little bit problem with video. That's why.
Oh. Now okay, na sir? Is it okay now?
Okay, then I need to restart. Yeah. I need to restart my system. That's why it's taking.
Okay.
I don't know why this camera is facing problem.
Maybe some.
Would it be fine then? Yeah, some cam problem is going on. So I need to restart again. It will take 2 minutes. And is it? I think is it required to show my video? I don't think so. Is it?
Sir, come back.
Yeah. So do you see me? Yeah. That's why that's why it is creating some problem. That's why I don't know why. It is showing here that is available, but I don't know. It is not giving me the option to take the login. So I need to restart the system. What do you? Yeah. Kiran?
Sir, just you can share your screen, sir. That's it. No need of your video. No problem.
That I can share. I'll share. Just wait. Now I'm checking the possibility that I'm running with another application. So
Okay.
just let me check whether this application is grabbing and something or otherwise. Then I can join. Yes, now I got it. Just wait. Now with the meeting ID that given that I'll be joining. Just give me just a couple of minutes.
Okay. Dear participant, sorry for the small inconvenience. So please be wait for the with your patience.
Yeah, Kiran, do you hear me now? So actually this is disabled. My camera has been disabled from my your end, I believe. I don't know. Anyways, just
we have given the presentation.
Yeah, presentation I'll be sharing.
Now it is okay.
Yeah, is it visible, guys?
Yes, sir. Yes, sir. We'll start, sir. Let's start, sir.
Yeah, it's okay now. Fine. Thank you.
My dear participants and today's resource person, a very good morning to everyone. Welcome back to online Day 5 Faculty Development Program on Artificial Intelligence, Machine Learning, Data Science with Research Application. It's a privilege to present the esteemed profile of our distinguished resource person. Dr. Ramesh DHARAVATH is an associate professor in the Department of Computer Science and Engineering at the Indian Institute of Technology, Dhanbad. He is a senior member of both IEEE and ACM with over 15 years of academic and research experience. Dr. Ramesh is recognized for his significant contributions in the areas of distributed computing, blockchain, cloud storage security, big data modeling, machine learning, and virtualization. Dr. Ramesh has held prestigious visiting positions at renowned international institutions such as the University of Aberdeen, UK, Warsaw University of Technology, Poland, University of Southampton, UK, and the University of Economics and Human Sciences, Poland. His work has been supported by national and international funding agencies, including the DHT, SERP, Government of India, and the PMU Cybersecurity Center, Saudi Arabia. He has supervised more than 8 PhD scholars and over 50 postgraduate theses. His research has led to high impact publications in top tier journals like IEEE Transactions, ACM Transactions, Elsevier, and Springer, along with multiple patents to his credit. Dr. Ramesh has also been the recipient of several accolades, including the Best Researcher Award, Outstanding Scientist Award, and multiple Best Paper Awards. Technologies like blockchain and AI to address real world challenges in healthcare, agriculture, and cyber security. So it's an honor to read this profile. Thank you, sir. Now I request Ramesh sir to take over the session.
Yeah. Thank you very much, my dear friend. I'm very sorry that I can't greet you personally, but because I don't know your name. So can you just reveal your name so that I can say my heartfelt thanks for introducing
Saptami,
me?
sir. Saptami.
Yeah,
This is
Saptami.
myself, Saptami.
Yeah. Thank you very much for introducing me to the community of today's discussion part. And on the other
We are
hand,
honored.
on the other hand, I also thank to Dr. Kiran for just inviting me to share my thoughts with this kind of um, prophylactic environment of various good persons. Hopefully, then we'll have mutual discussion and probably we may get suitable insights together. Thank you. So just confirm two things from my end. Then I have already displayed the first page and just do confirm whether the slides are moving or not. Moving, right?
Sure.
Yeah. Okay.
Yes, sir.
Yeah. Okay. Thank you. Thank you very much. Then yeah. Okay, guys. And first of all, please accept my apologies that I have joined 10 minutes late and I made you wait. Hopefully, why? Because time is the very important constraint for everyone. So just now I had finished my database management system lab, which was started at early morning 8 a.m. Anyways, then let's do in a mutual way and please keep your patience stronger up to some extent. So at the end, probably at 10:45, 11:45, that I'll give you some time for possible discussions in terms of share. Yeah. So deep learning. That basically you guys are having knowledge on the part of this deep learning, but just I would like to let you know that what exactly we are doing professionally with basic fundamentals which we understood. So why I'm saying like this in the sense, see, this era is of only utilizing the libraries, drag and drop, drag and drop. So if I drag and drop a library name, say decision tree, then what basically the decision tree rendered with a specific fundamental concept that we do not know until and unless we solve the problem of decision tree in terms of at least calculating Gini index and entropy type of mechanisms, then you will be able to understand. Yes or no? So this insight intuition that we must and should know. So that's why that I kept this title as Inside Deep Learning, Concepts and Intuition, generic way. Okay, so if you have greater knowledge and even high-end knowledge on these deep learning constraints and concerns, it would be a very happy to know from your end as well. But let's do that. I'll try to exemplify the things and make you understand with the basic prerequisites of deep learning why this part is required, how we are going to take this part ahead, and where we are going to deploy, and how we are going to use this. And after doing this, what is the application phenomenon we experience. So that this is about a simple introduction on the part of this inside deep learning concepts and intuition. Okay, so let's do with nominal discussions first. So mostly the people are having a kind of illusion, right? So the journey of machine learning will give you sufficient knowledge of deep learning. Fine, it is good. But what is the way to approach? Right? With what constraints or with what fundamental or phenomenal knowledge we gain, then how to move forward to carry forward the machine learning constraints which can be embedded into the realistic applications so that we can perform more. We can perform more in this domain. So let's start with the let's start just by knowing the major difference between these two entities or themes. Okay, so understanding the latest advancements, people are chanting AI, AI, AI. So from where this AI has come, so you can reach up to the level, my dear friends. So starting with generic AI, okay, starting with generic means normal AI, fundamentals of AI, and followed by generative AI, followed by explainable AI, followed by a top level of understanding that is agentic AI. Now you tell me what exactly we can differentiate among these individual subentities of AI. Yeah. So nowadays people are chanting like anything AI, AI, AI. From where and how basically the concept of AI has been constructed to carry forward the application management process. Yeah. So let's understand the latest advancements in AI, which are really overwhelming nowadays. But its basic learning is quite interesting. So with this basic learning, you can boil many AI innovations down to the concepts. That is two major fields, that is ML and DL, vice versa. Okay, ML and DL. As a prerequisite, you must and should have the clear-cut fundamental knowledge of solving the problem by using machine learning paradigms. Why I'm saying here in the sense, I cannot apply the same machine learning algorithm, right, to different problems. Yes, then when we change the problem, then modality of machine learning will also be changing. Somewhere, somehow, sometime, we need to apply more deeper knowledge, right? Deeper knowledge, right? In a fascinated way to construct and gather the realistic output in terms of prediction perspective. So that's why we require the basic understanding on these two fields, ML followed by DL. This is the meaning. So simple that you know that just let's start with the realistic applications we are witnessing today. These ML and DL are everywhere. People are saying like, okay, what is this? This is DL technology. This is ML technology. Fine, but how it works? Simply taking the data set and dragging the from this and showing the prediction. Is it? So we are forgetting something here. It's working structure. How this algorithm is working with respect to the data set, right? And the data set is having so many constraints. So starting from the problem of first thing, that is that whether the data set is realistic or not. Up to what extent your data set is realistic means it must and should contain original information. If you do not find the information or suitable insights from the data set, whatever the XYZ algorithm or advanced algorithm you apply, you cannot get the required insights. So that is the way. So it's what makes like self-driving cars in reality. So it's a physical entity, car is a physical entity, engine is also a physical entity, but it's working something based on the intelligence virtual intelligence provided. But how it is converged into the reality? Can anyone explain me? Don't say the answer like this, like just it is algorithmic dependent and the prerequisite knowledge or pre-knowledge given to the algorithm and according to the machine is behaving. Absolutely wrong, my dear friends. This is wrong, right? So just think from your end. It's what makes like self-driving cars in reality and how again that Netflix knows which show you will want to watch next based on the previous experiences and how Facebook recognizes whose face is in a photo. Simple example. I'm speaking traditional way of computing, my dear friends. Yes, hopefully you'll think about this. Now moving towards these two fields seem like interchangeable buzzwords. ML followed by DL, sometimes DL followed by ML. But basic prerequisites must and should know from ML. But there are differences between these two. So what exactly are these two concepts that dominate conversations about artificial intelligence? Generic way I'm speaking again. Okay, about AI and how are they different? So we must and should know prerequisites like intuition behind. So let's do with that. So if you consider the stack of AI, okay, stack of AI, still I'm doing 70% work, but frankly speaking, not able to define what exactly AI performs. Okay, why? Because I'm completely dependent on the prerequisites I have gained in terms of problem solving, okay, for machine learning paradigms. Somehow, sometime, if I don't feel flexibility, I'll go more deeper by establishing new constructions. I'll go more deeper by establishing new constructions or new designs. So that's what we call it atomic today, deep learning. Yeah, absolutely. But we mustn't should know why are we going towards to the range. Okay, if you are lacking something, define this. Yes, my machine learning algorithm is not able to perform up to the extent. So that's why I need to establish some extra management of computation, processing, and algorithmic design as well. Okay, so artificial intelligence to ML followed by deep learning, whereas the stack of artificial intelligence is also completely depending on these two strategies. So what says that simply it's a common behavior or common intelligence. You can simply call virtual intelligence converts into the reality. What do you mean by this reality? That is, you are giving knowledge to the system to work based on the pretended mechanisms deployed to that. That's it. So that's why artificial intelligence has been recognized as a science management component. This is devoted to making machines think and act like humans, not exactly like humans. They perceive only from humans, and the intelligence gained by the humans, they do. That's it. Okay. Now, coming to the part, then it's a kind of devotional entity, I would rather say. Machine learning is a devotional entity to the artificial intelligence. Why? Because this machine learning completely focuses on enabling the machines, computers, to perform the given tasks without explicit programming. If I fed X, it will work based on X only. Even if I fed or feed the combination of X in terms of sub-entities, X1 is something, X2 is something, X3 is something, X4 is something like this. That's it. And based on the knowledge given with respect to X1, X2, X3, this will work. So that's why it is written there. That is, ML enables the computer to perform, or the machine to perform the task without explicit programming. It means it won't go beyond the prerequisite knowledge or predefined knowledge or pretended knowledge is given to that machine. Okay, so there is a boundary for machine learning. Now, can you solve the problem, or can you make the limitation of working with a simple data set or a kind of large data set which involves with different type of constraints, right? By considering one simple machine learning algorithm? No. Why? Because every machine learning algorithm has its own creation, own reputation, own management, own design, and way of working. So that's why there is a need to extend the machine learning mechanism up to some extent, means beyond the explicit programming. So that's what we call it as deep learning. So this is a subset of ML. Okay, and this is completely based on the design we deploy for machine learning with artificial intelligence. So combination of these two. Now machine learning won't solve the problem. Okay, won't solve the problem with the help of artificial intelligence. Why? Because it requires deep insight mechanisms, okay, to be floated. So then only the problem solution can be stated with the reality. Otherwise, no. Okay, so this is a simplistic representation and explanation about AI, machine learning, and deep learning. So now let's go to the problem gathering, right? Means problem mechanizing part. Means we are going to create the problem first. Okay, and based on the creation of the problem, we choose the parameters. Initially, yes, this step must be solved first, followed by second step solution, followed by third step solution. So this way we iterate the solution and perform the computation, right? So let's do this, sir. Then AI versus ML, if you include, it is basically a mechanism to incorporate simple human intelligence into machines through a set of rules. You can simply call what we call set of rules. You can simply call different type of paradigms, and these paradigms we are referring as algorithms. Again, algorithm is specific set of steps. You cannot solve the problem straightforward. Starting with simple program, that is finding leap year program by applying for loop, by applying one inner for loop, by applying two inner for loops, by applying one inner for loop and one outer for loop. There you will see the difference, guys. Simple example. So your solution is completely data dependent, not algorithmic dependent. So that's what we incorporate. So this human intelligence into machines has been converged through a set of rules, right? If something goes wrong, go to next point. If something even goes wrong, go to another point. So that is the intelligence we are giving to the machine. That is AI. Okay. Now, AI is the combination of two words again. Artificial means something made by humans, which is not natural, means non-natural things, and intelligence meaning like the ability to understand or think accordingly. Yeah, something made by humans, that is artificial, and that artificial thing that we are going to solve or we are going to convert for solving some problem by applying some intelligence, that is called knowledge. Okay, like data, metadata, metadata to metadata, metadata to metadata. So I'd like to know that what movie is running in INOX today. So if I say some XYZ, so where is the location of that? Location is some A. Okay, then that location A is having multiple screens. What is the name of the screen where this XYZ movie is running? See again, data to metadata. Running this movie somewhere is data, and knowing somewhere, knowing about that movie is running some location A, that is metadata, and again knowing about the screen at that particular place of A, metadata and metadata, data about data again and again. See, so this way we are converging the intelligence towards, right? So if I stop just knowing that, yeah, this XYZ movie is running someplace. I need to search for this, right? So in order to search for the location, then again, I need to apply some intelligence. See, that's what the process of deep learning comes in picture. Okay, yeah, and come to the part of ML that in order to prepare or in order to arrange a basic platform to apply the artificial intelligence that we can refer as ML. So this ML is basically the study or process which provides the system that is called what? Your machine to learn automatically on its own through experiences, right? And accordingly, it can also be improved without being explicitly programmed. Why? Because that you have created the boundaries in terms of deploying your own knowledge, that is artificial intelligence. That's why based on the artificial intelligence provided to the machine, it will work and will try to solve the problem. So it won't go beyond. So that's why it is written here. It had and improved accordingly without being explicitly programmed. So it won't go beyond. So if it is going beyond, now the machine is out of control. It will start behaving randomly, and it will go beyond your control, and it may also create some problems to the human that who has created the intelligence for solving a specific problem in terms of artificial way or in the way of artificial structure. Okay, yeah. So finally, that what we can treat here. Should we treat that ML is a kind of required mechanism for AI? Absolutely not. So this is an application of AI or subset of AI. I would rather say it's an application of artificial intelligence. Why? Because this ML focuses on the development of programs based on the problem we frame so that it can is realistic or not. If the data is not realistic, what should we do? Again, we change the modality of the data. We change the sample of the data before or prior to considering the population. So we can draw a possible pattern from that, and accordingly we can solve the problem. So this possible pattern is being formed and make better future decisions as per the examples provided to the machine. So this way we try to solve the problem. So finally, what we can treat, guys, so we can treat that machine learning is an application of AI, of artificial intelligence. Now, it is fine now. Then can we make the limitation just by creating some suitable paradigms in terms of ML algorithms for some problem solving domains? Absolutely not. Absolutely not. Say, given an entity like a car to me, that I want to change the modality of the car, interior of the car, that I can do. So in order to do this, then I must and should have clear-cut goal so that I can see my car as a design luxury entity. So for this reason, you need to have the knowledge beyond the ML creation, that is called deep learning. That is called deep learning. Yeah. So let's see that what basically it provides or represents or gives us the construction strategies to go beyond the ML capacity, right? So this is a subfield even. Okay, you can treat ML is the application of AI. Okay, application of AI. Why? Because we create problems, we create solutions, and we merge together and we find out suitable insights. So what we do now, again, we can treat this a kind of network as a salt bridge between the creator, that is called artificial intelligence domain, and the subdomain or application that is called ML. So what is the convergence between these two? That is network. That is network. So without creating the network between these two or establishing the network among these two, that you cannot perform any deep learning mechanism. So this deep learning strategy has been treated as a subfield of ML. Please mean it here exactly what it says. Machine learning that structures the algorithms. That structures the algorithms in network layers. Layers to create neural network. Network is for communication combination, and performing some processing we need to have neural creation, and that neural creation that we are taking are considering as a transfer learning in terms of artificial intelligence. See, three different terms we converge together. Network for moving one-to-one entity, and neural for processing mechanism, means some logic we are going to embed, and that logic that we are deploying in an artificial way. So that's what the combination of deep learning has been framed. Otherwise, no. So without establishing this network and neural, there is no meaning of working with deep learning. So this subfield creates artificial neural network that can learn and make intelligent decisions on its own. So that's why the process mechanism has been named as deep learning. Okay, so let's see the prerequisites of this part. So deep learning is basically again a subpart of the broader family. It's simply called of ML. What it does basically, so which makes use of neural networks. Use of neural networks. So without deep learning, then what's the need? Straight away you can apply y is equal to x plus b, standard strategy, or yi is equal to w1 x1 plus w2 x2, weight followed by its input, weight followed by its input, just combine together, you'll get a straightforward linear combination result. Yes or no? What is the use of that? Until and unless you use the neural networks with a different modality of convergence in terms of testing your intelligence, in terms of testing your intelligence, where or whether your intelligence is going to provide suitable insights from the data after taking the neural network combination for. So this is similar to the neurons. Even I found a same functionality changing time by time. And so likewise, this neural network mechanism can be utilized to make sure the deep learning process more suitable. That's one. And finally, this machine learning which makes use of neural networks similar to the neurons working in our brain to just mimic human brain like behavior. So I can conclude something here. So with machine learning, you cannot say that the system is mimicking human brain like behavior. Why? Because the machine learning is not the destination which can solve all the problems with the provided paradigms. Please write down this. So whenever you go beyond, like adopting explicit programming, means you are doing something extra beyond the paradigm of beyond and aligned with the paradigm of the machine learning, then you'll be able to draw required and nearby approximate solution, right? Because that system started mimicking like human brain. Yeah, so that's what deep learning strategy is required. So DL algorithms, let's do now. So we concluded. So for what reason that we are making sure with deep learning means here with the help of deep learning that we can focus on information processing patterns in different ways or patterns mechanism to possibly identify the upcoming means suitable representations in terms of outcome, just like our human brain does, and classifies the information accordingly. Simple example, I had seen different type of cloths of different colors. Okay, blue color with bordered lines, with checkered lines, say 4 colors only for 4 variations in blue. So if I take say 7 colors, 7 4 is 28. So now I started watching like this, like this, like this. So someone is asking, what is there at the 14th position with what color and what is the pattern drawn? Can you say, can you give the solution for this? Impossible. Why? Because the minute design is there so that my eye cannot catch, but I can feed the information to the system. Yes, I have seen and observed these patterns with respect to that particular 14 image, and I'll say the system to train accordingly. See, that's what the processing pattern mechanisms comes in picture. Okay, so what I'm concluding here in the sense, the deep learning algorithm basically focuses on information processing patterns mechanism, not gathering, please. Okay, information processing pattern mechanism, not gathering, to possibly identify. Why? Because the information gathering has already been done and stored into the system. Now what is left with? That is information processing pattern mechanism left with to possibly identify the required pattern. Just like your human brain will think, oh, I had seen this one, it might be wrong. Oh no, it might be right. If something is going wrong, then what I left with or what I forgotten. See, you can interchange your solution. Oh, I could have done this in a different way, so the result would have been come in a different way. See, this way means changing the thinking strategy dynamically, and this knowledge you are giving to the machine in terms of information processing pattern mechanism. That's what deep learning follows. That's it. Data feeding, okay, data feeding, data gathering, data feeding, data pre-processing, classification, everything you can do with the machine learning strategies. But you cannot force a machine to process the patterns for suitable mechanisms in terms of identifying the required output with machine learning. That is not possible. So that is possible only with deep learning. So this is the second prerequisite you must and should know about deep learning. And the third one is that you can ask me a question like, can we apply the deep learning for smaller sets of data sets? Okay, you can apply, but as the deep learning strategy has come up with very expensive mechanism of drafting, knowledge drafting. So though you should not waste it. So mostly we try to apply the combination of larger sets. So DL works on larger sets of data as are when compared to ML and prediction mechanism in self-administered by machines. So if you make your system should be self-administered, then you can apply on large quantity of the data sets. Why? Because the large quantity of the data set has different types of insights. So in order to reveal, in order to gather, in order to examine, in order to preserve suitable insights from the large sets of data set concerns, DL is more suitable mechanism to consider. Yeah, so that's what the deep learning speaks about. Okay, now hopefully you understood the theme of our discussion. When, how, why this deep learning strategy can be taken into consideration. Okay, so you can simply treat yourself that this is beyond the limitation of machine learning. So deep learning is beyond the limitation of machine learning. So that's what it says. Right, now the basic question comes like, how does DL work? Everyone knows. Can you give me specific reason? Anyone? Guys, how does deep learning work basically? As I told you, the basic prerequisite in terms of establishment is the network, neural network. Okay, neural network, NN. And that neural network is framed artificially. So the basic step to create and examine the mechanism of deep learning creation must be based on network, neural network. Right? Let's see that how it works. So this is a model we consider designed to continue means continuously or continually analyze data with a logical structure, right? Similar to human brain, how human would draw conclusions. It is not beyond even. Your human brain is much better. Why? Because if something patternized type of problem is considered, sorry, is or has seen in the data, then the concept of explanation and concept of drafting the result will go beyond. So even you cannot conclude that why it has gone wrong. Okay. So to complete this analysis, we consider the deep learning applications use that is called layered structure. So this layered structure we arrange on the name of neural network. So there is no concept of deep learning without neural network. So algorithms called that is artificial neural network. Now you tell me, even if I make the classification, okay, I can give you the challenge now that I'm going to perform the classification by using any kind of supervised learning algorithm. Let me prefer, okay, let me prefer random forest classifier. Now I'll do with ANN classifier. What would be the modality of difference that you will observe? So definitely there will be a change. Even in generating the output, deep learning network may take extra time. Doesn't matter, guys. But your result would be accurate enough as compared to normal classification or classifier mechanism you apply. Got my point? Why? Because deep learning strategy has been applied, deployed, tested, and finally drawn with the help of artificial neural network. You can do wonders with artificial neural network. Still, there are so many problems that you can solve good number of problems with neural network, except the latency related problems. And that is complete depending upon your algorithmic design. That's what. So finally, the design of an ANN, artificial network, is inspired, by the biological neural networks, BNN, of neurons in the human brain, which leads to which leads towards learning the system that is far and far more capable than that of the standard machine learning model perform. Now you got the difference, I believe, right? So a simple challenge. You can think yourself, what is the reason that I had applied the concept of a simple what we call classification algorithm, right? In terms of ML stack. Then if I go beyond and if I perform the classification by using artificial neural network classifier, then what would be the difference? Why it must happen? Yes, you can get it. That's what. Now moving towards that, finally, that we can conclude this deep learning strategy as it's a tricky prospect. Why I'm saying, if I say multi-layer perceptron, or starting with perceptron of ANN problem, okay, ANN simple perceptron, okay, multi-layer perceptron. Now you just examine. You can examine now. You'll feel the difference, guys. This is not that much easy. Why? Because at each and every iteration level, we need to test the weights. Accordingly, we need to adjust the error. Again, if you don't satisfy the error with the error, again you have to go back. Again, adjust the weights. Again, perform computation. Find out the error. See how this is. A deep learning model doesn't draw I'm sure, incorrect conclusions like other examples of AI. So it requires a lots of training to get the learning process correct. So we can assure that at least then basic examples nowadays. Perplexity, OpenAI, it's a good one as compared to ChatGPT. Why? Because it gives you relevant information with the background knowledge from where the knowledge has been drawn. ChatGPT is not like that. Yes. So, but when it works as it's intended, deep learning is having a kind of intention provided provided in terms of artificial intelligence, right? So this we term as this functionality of learning. Okay, this we term as this is ANN model, right? And we are just dragging something and we are applying, we are putting some implications here, and this is called functional deep learning strategy, when exactly we apply our knowledge realistically. So when it works as its intended, functional deep learning is often received as a scientific marvel that may consider to be the backbone of the true artificial intelligence, not the partial of artificial intelligence. Partial would be false positive, for partial would be false negative, false positive, false negative. But this deep learning surely renders the true artificial intelligence as a backbone in terms of realistic output, providing realistic output. That's it. So this way the deep learning works with what? Artificial neural network framed mechanism. Structure is same, but we are keep on changing. Okay, we are changing the mechanism of ANN. Say initially I started with two layers, one input layer, one output layer. Later on, I'll include more layers, hidden layers. So when I include hidden layers, the capacity of learning also increases, the capacity of examining also increases, the capacity of making intuition is also increases, changes, right? Layer to layer. So that's what the strategy of deep learning is required here. And this way, the deep learning works, right? So simple example I'm providing for your illustration, for your understanding, and for your perusal, and for your reference as well. Okay, so a strong example of deep learning is that I'm not quoting this technology. Why? Because I don't like. Still, I'm not finding relevant information even sometimes. My usage is only for 5% for ChatGPT, only 5%, and that 5% I don't rely on that. Okay, so strong example of DL, that's Google's AlphaGo. Initially, Google has created a computer program. It's not a new thing, guys. So still it is running in the background of Google engine. Okay, with its own neural network that learn to play the abstract board game Go. Board game Go. Right? So which is known for requiring sharp intellect and intuition. Like even say if you give the knowledge to the system to play chess. Okay, previously program might have written to solve the problem within 6 to 8 steps, but it may also solve the problem within 2 to 3 steps. Who knows? So this is completely depending on the sharp intellect intuition. I'm saying now. So this we are capturing. Okay, and by playing against professional Go players, okay, normal one, AlphaGo's deep learning model learned how to play, see, at a level never seen before. At a level never seen before in AI, and did so without being told when it should make a specific move intelligently. Means as a standard machine learning model would require. That's what. Now again, so you can ask me a question, the professor, what type of intelligence has been deployed to make an intelligent move that we had not seen ever and even before. So this is completely based on the intelligent aspect, means perspective deployed towards. Yeah, and for more practical use cases, you can simply call, imagine that again, an image recognition app. Even you can say that even if you have Google Photo Library, then if you have 15 to 20 friends, then you might have taken photographs with them in the past. Then it will locate their name along with your relation, association, everything. See how the knowledge has gone far, my dear friends. So imagine an image recognition app that can identify a type of event, a water bottle, a Lord Buddha, Lord Krishna idol, like this, or species of a bird based on a photo. So that image classification is powered by deep learning neural network. You can simply call DNN. And on the other hand, DL also guides speech recognition and translation and literally drives self. So what here we are witnessing today. Oh my God. Yes. So let's see that. So this is working now. What are the variants of deep learning? So machine learning can enable computers to achieve remarkable tasks, no doubt, but they still fall short of replicating human intelligence. Whereas we can fulfill this responsibility with the deployment of DNN, on the other hand, where these are modeled after the human brain, representing an even more sophisticated level of artificial intelligence can also be represented, can also be deployed. Okay. So let's start with its variant as a convolution neural network, CNN. What do you mean by convolutional? I use it to ask my students when they come with basic learning. So neural network part is fine. Okay. What do you mean by convolutional? Convolutional. So you must should have some specific logic. So that's why you have considered this word or fixed this word before or prior to neural network stuff. Right? So convolutional neural network in the sense, again, CNN are algorithms specifically designed for image processing and object detection. Don't think like this is only for image, but in the background, something is working on the name of convolution. That is a unique process of filtering. Unique process of filtering. It's a kind of knowledge-based variant. Okay, our solution you can simply call has been applied through an image to assess every element within it. So let me compare that just for last 2 months. From last 2 months, I'm doing like this. Okay, then in the month of April, I had, hey, now if I give this kind of posture with the same image, then my system is able to identify last 10-year pictures of mine with the different dressing, different style, even with all. So that's what the convolutional speaks here. It's a unique process of filtering through. If I apply image, it will go through image. If I apply through a standard process, it will go through a standard process. By assessing every element within it, I'm speaking here. So even if you consider image or even if you consider other domain of variant, it will assess every element within it very deeply. So that's what the term convolution came in existence. Okay. Now moving towards CNN are often used to power computer vision. So it's a good framing domain, right? Giving more flexibility of luxury life today. Computer vision, a field of AI. Basically, it teaches the machines how to process the visual world that we have reached up to the level of virtualization, virtual creation of physical entities, guys. Fascinating, right? So starting from facial recognition technology or even deploying your physical entity information of digitization into virtual mechanism. So digital twin technology has come up. Okay. Now, again, that this I'm not going to read the same functionality that I'm placing here. ML can enable computers to achieve remarkable tasks, but they still fall short of replicating human intelligence. So that's why the concept of deep learning networks has been forwarded are considered on the other hand and modeled after human brain in order to represent an even more sophisticated level of artificial intelligence. Okay, the first variant we had seen is CNN, convolutional network, and neural network, meaning we know. Then I gave you the meaning of convolution, that for what reason that convolution has come up. Now, the second one is RNN. Again, recurrent. So this knowledge has been reconnected from long short-term memory, LSTM. Say if I write something like, say, PhD. Why are we calling it as Doctor of Philosophy? Why don't we add T in front of PH? TPH, it will become rather. See, a simple example. I'm feeding the information as a PhD, but the system is reading in a different way. See how much intelligence that you applied here. Doctor of Philosophy. Or PHP, if you write, Paul PHP, you can simply call. See, we have plenty of examples to solve even word-related problems. So if we apply the speaking criteria mechanism to the system, see the system is behaving like a human here. Okay, recurrent, applying back this way, applying back some output. So this output I'm not feeling relevant. So again that I'm applying to examine, fed, and the this again I'm getting the new outcome. Recurrent neural networks. So what it says. So these are built. Okay, these are built in feedback loops that allow the algorithms to remember past data points as well. So as compared to as compared to the CNN limitation, RNN can use this memory of past events to infer their understanding of current events or even predict the future as well. Okay, so this is having a different mechanism frame or framing mechanism. Finally, that a deep neural network can think better when it has this level of context, not only image, not only speech, not only other. Okay, the motions, combination of motions, image followed by audio. Okay, and realistic movement of human being with audio, converging with visualization, converging with what movement. Everything is combined now. So how it has become possible? You tell me now. It's because of deep learning application. So for example, a maps app powered by RNN can remember when traffic tends to get worse. It's a better experience for all guys mostly. So it can use the knowledge of previous outputs in order to recommend an alternate route when you are about to get caught in rush hour traffic. See, it seems like a generalized application, guys. Simply say what bottle you are taking or what bottle that you just consider to fill the water. If I say this bottle, oh, this bottle is, see the patterns, how beautifully this bottle is designed. Do we ever seen this? Means this is the context that we need to understand, guys. Means what's happening inside. But intuition I'm speaking now. So that intuition gives you more flexibility in terms of creating your own hands-on solution. So that's why knowledge is the limit for deep learning. Yes. So that need for DL data as the fuel of the future. Absolutely. Hopefully that you will agree with me, right? Data is the fuel for the future for anything as well. So where with the massive amount of new data being generated day by day, produced day by day, the current that is called big data era, we call it as a term. So we are bound to see innovations that we can't even imagine yet. So we can play with the data, right? We can play with the data to generate more and more suitable insights, right? So according to the data science experts, some of these breakthroughs will likely be deep learning applications. Okay, visualization I want to do. visualization I want to do. Flight is taking off. Flight is going to land. Okay. So where is the visualization? So what breakthrough that you can create? So this is because of deep learning only. So finally, what it says like this guy, Andrew Ng, former chief scientist of China's major search engine, Baidu, this is called, and one of the leaders of the Google Brain project shared a great analogy for deep learning models with White. Okay, now see, as per my perspective, that AI is akin to building a rocket ship. Good, but you need a huge engine and a lot of fuel for that. So he told, this guy told, no, Andrew Ng told that wide journalist Caleb Garland. So if you have a large engine and a tiny amount of fuel, you won't make it to orbit. True, no? Why? Because that you don't have the data produced, tested. So if you have a tiny engine and a ton of fuel, you can't even lift off. Yes or no? You mustn't should have some prerequisite knowledge to do the same. What will happen after what? What will happen after what? So that is your data perspective. That's why need of DL. Data is considered as a fuel, right? Another statement, to build the rocket that you need a huge engine and a lot of fuel. But the analogy to deep learning is that the rocket engine is the deep learning models and the fuel is the huge amounts of data we can feed to these algorithms. That's what that I can define the need of DL logically and interestingly, I would rather say. Yeah. So now, fine. Then we understood the theme of everything now. That is how AI passes and how ML moves and how deep learning performs. Good. Now the basic question comes in our mind now. How can we use learning to progress towards AI? Then one thing I can say straightforward way, until and unless you examine something at your own and solving the problem with your own hands by developing code snippets, then only you can understand how exactly that you can use the learning to progress towards AI. Right? The basic question comes. Can we find learning methods at scale? My dear friend, initially you do not know how that analogy of classification works. Fine. You must and should know it's working, and you must and should have a clear-cut problem-solving example in your mind. Then only you'll be able to feed. Yes. Second question: can we find learning methods that solve really complex problems and end-to-end, such as computer vision, such as natural language processing, such as speech processing? Is it? No. So you are opening one browser and going to the Google Translator, then just clicking on that, just enjoying the amenities. But my dear friend, how logical transformation has been performed, has been considered, has been deployed and deployed. Do you know that? So that's what this process. How can we use learning to progress towards AI comes in picture, right? So this is the solution from my end for this. Now, second question: how can we learn the structure of the world? Mind-blowing question, you know. So what is that? That how can we learn internal representation of the world that allow us to discover its hidden structure? Again, that you must and should understand the working structure of the paradigm or the algorithm you deploy. Okay, how can we learn internal representation that capture the relevant information and simply eliminates the irrelevant variabilities? So until and unless you know the structure of that paradigm, then only you can do this. Yes or no? Say my shirt size is XL. I got freely 10 to 15 shirts, but I don't know the size of that. I started wearing one by one, but no shirt got fit. Now I can give the conclusion. What is the conclusion? I don't know. I don't know the size of the shirt. That's why I tried. So it's a waste of time, waste of processing, everything. So that's why you must and should know some relevant information. Yes, even you have seen when you go to the shopping, you search for good color, good cloth, everything, and obviously go for the size. So without size that you cannot select your shirt, yes or no? So this is the relevant information which eliminates irrelevant variables. Yes, guys, this is a solution. Now, third question that I had framed here, that is, how can a human or machine learn internal representation or learning? Can simply call, there is a typo, please excuse me. And machine learning internal representations by just looking at the world. Can we do it? No, no, it is not possible. It is not possible. So the next 20 years in machine learning, that is learning representation, is required seriously. So the big success of ML has been to learn classifiers from label data. Okay, that you're supposed to do. Even if you compile extremely high standard work and made a great publications, even IEEE transaction doesn't matter. If someone asks you, my dear friend, please just do explain me how this process went on, then if you are not going to explain the mechanism of it working, it's wastage. It goes into dustbin. I'm sorry, dustbin is also having some value. Yes, so the representation of the input and the metric to compare them are assumed to be intelligently designed for classification algorithms. So one must and should have the clear-cut knowledge on its working. For example, so let me consider SVM, support vector machine classifier. So it requires a good input representation and good kernel function. Can I ask you a question, guys? What is the variation of kernel function? What, for what reason that we are considering why it is represented? So can't we solve the problem without kernel function? Yes, see, this is the added advantage of support vector machine. So SVM itself has been considered as an intelligent classification entity, but still something is lacking. Okay, now the next frontier is to learn the features of the dataset. So without analyzing, you cannot apply it blindly. If you apply it blindly, you'll get blind result. If you follow the blind result, then you'll be able to face the difficulties. So the question comes that how much or how can a machine learning good internal machine learns good internal representations? This is the question you will define. In language, good representations are paramount. Yes. And what makes the words cat and dog semantically similar? Just tell me now. How your system is able to represent the difference among these two. See how logically, how intelligently, right? And how dramatically, how dynamically this idea was familiarized. Okay. How can different sentences with the same meaning be mapped to the same internal representation? Guys, just think about this. So how can we leverage unlabeled data? That is for label one, so which is plentiful. So my answer is plentiful. So this is a simple example that I would like to show you. The traditional shallow mechanism, that is architecture for recognition, pattern recognition. See, so this is the image that I had considered. I may consider that is pre-processing followed by extraction. So this part is mostly handcrafted. We can do this. Yes, from this, we are going to draw internal representation. That is very simple, trainable classifier. You are training the classifier. So the steps are as follows. The raw input is pre-processed through a handcrafted feature extractor, obviously. And here, initially the features are not learned. Okay, so the trainable classifier is often generally treated. That is called task independent. Yes, and simple. It may be linear classifier, it may be kernel machine, it may be nearest neighbor, whatever. Okay, so the most common machine learning architecture here That is a kernel machine. You can use it. So this is a traditional style architecture for recognition. So moving towards, see, the next challenge of ML, that is vision and neuroscience. So how do we learn invariant representations now? Same. Just see here. So from the image to an airplane, how do we extract a representation that is invariant to pose, illumination, background, clutter, object instance, and its physical movement? What? So how do we learn invariant representations? Again, we need to deploy suitable knowledge. Then, based on this, how can a human or a machine learn those representations by just looking at the world? Yes. So you need to do something extra here. So I'm speaking a little bit theory, my dear friend. So I cannot make you understand logically. Why? Because I need to sit along with you as an agentic AI. So how can we learn usual categories or visual categories from just a few examples? Here, so I don't need to see many airplanes before I can recognize them. Yeah. See this. Just think with common sense. Okay. Moving towards good representations are hierarchical. So your solution may change dramatically time by time. So see, this guy is doing something here. From this, the trainable feature extractor part is drafted. From this trainable feature extractor, again, from this, see, this is going layer wise. Finally, a trainable classifier comes in picture. Okay, so in language, we speak like this: hierarchy of syntax, or hierarchy in terms of syntax and semantics. Syntax means giving suitable stage of language with, and semantics is checking its meaning. So words, parts of speech, we check. Sentences, part of speech, followed by sentences, followed by text, right? And objects, actions, attributes, phrases, statements, stories like this. Even if you consider image in vision, whole hierarchy, pixel to edges, edges to textures, textures to parts, parts to objects, and finally you'll be able to see that scene. See guys, so these parts, textures, edges, pixels were hidden here. So what we want? Yes, Leelavati ji, please tell me. Any question from your end? So let me do just for 10 minutes so we can take. Yeah. So finally, so what we are learning here, we are learning the internal representation, that is called deep learning. So learning a hierarchy of internal representations in what? So don't do like, yes, I know the working of algorithm, my dear friend. This is the first step we fall into the dirty water. So even if you know, try to examine that up to what extent this algorithm can work realistically for the considered data set. So learning a hierarchy of internal representations are as follows. That is, from low level features to mid level invariant representations to object identities. Followed by representations are increasingly invariant as we go the layers. Right? So this is called invariance dilemma. Why? Because trainable feature extractor I'm identifying, trainable feature extractor I'm identifying. From each and every individual trainable feature extractor, I'm learning internal representations. So using these multiple stages gets around a specificity that we call it as invariance dilemma. Finally, we'll fix with the internal representation mechanism. Learn. Okay, so the primates of visual system is deep. I would rather say the recognition of everyday objects is very fast process. Very fast process. So that's why the recognition of common objects is essentially forward. Feed forward, test it. Feed forward, test it. Identify the error, reduce it. Again, go with the changing mechanism of weights and some inputs. Do it. Finally, you'll be able to see. But not all of vision is feed forward. All visions are not feed forward. So much of the visual system, all of it, is it so? Is the result of learning. So what is the prior structure? What is that? Say, you can ask me a question. Sir, if I consider CNN, how many layers I can consider? Even if I consider RNN, up to what extent I can go? So what learning algorithm can train neural nets as deep as the visual system? So that is called 10 layers. Right? Along with what type of mechanism that you would like to apply and deploy, whether it is unsupervised or supervised. If you apply so, then what is the loss function? Okay. Then what is the organizing principle? Right. A broader question. What is the learning algorithm of the neocortex? See, so that is the mechanism that you need to adopt. And obviously, we can approximate any function. Okay, kernel function, if you consider like this, y is the combination of what? Functionality of each and every kernel function I'm saying just by taking only 2 layers of neural network. Okay, so we want with shallow architecture, why should we need deep ones? So that is called, see, the deep learning machines always focus in terms of including, see, if this was the criteria I had resolved, I was not feeling satisfactory. So I go beyond, even I go beyond like this. So finally, what I conclude here is that the deep machines are more efficient for representing certain classes of functions. See, f of w naught dot x is a function involved in visual recognition, but I was not satisfied with that. So I applied this term of mechanism in resolving the error I observed in next layer. So they can represent more complex functions with less hardware, right? So that's why that we are increasing the capacity of computation in terms of graphical processing. Okay, structures. Okay, so what we want here, so we need an efficient parameterization of the class of functions that are useful for artificial intelligence tasks. So from this, I can give you a kind of conclusion, that is what AI task that I had considered here. See, so this was the primary function, could not able to resolve. Again, I applied some modality to this and again changed into w power k minus 1 kernel function with this multiplication. Somehow, somewhere, I could get some realistic information, but still I was not satisfied. Again, I tried to change the modalities. Again, I applied another function. And finally, I satisfied with the modality design where it was changed with the w power k. See, that's what. So how I get to know? I got to know, guys. Why? Because I tried myself. I stuffed myself, right, in solving that. If I apply this, what will happen? If I don't apply this, what will happen? So that's what you require. And this way, you can converge the intelligence into its working. That is programming. Okay. So see here. So why are deep architectures more efficient? There is no limit, guys. So I'm starting with one example. Okay. But I want to check n-bit parity. I want to check n-bit parity. I want to locate. So it requires n minus 1 XOR gates. Guys, just please minute. If I want to solve n-bit parity problem, it requires n minus 1 XOR gates in a tree of depth of order of log n. So how would I concluded this? How I came to know that n minus 1 XOR gates are required if I apply a tree concept of up to depth of log n. Why can't I fix with the order of n or even order of n log n? See, just why? Because some relevant case study has been done. What is that? So in order to recognize the n parity mechanism with n minus 1 XOR gates requirement up to the depth of log n depth tree, it requires an exponential number of gates of we restrict ourselves up to, just see, 2 layers. 2 layers. Now you apply. Okay. with exponential number of min terms. It's up to you. Solve the pattern. This is the knowledge given to the system. Now, example 2. Circuit for addition of 2 n-bit binary numbers. I'm giving you the problem. Solve it. Circuit for addition of 2 n-bit binary numbers. So now the modality has been changed. It requires order of n gates, okay, and order of n layers using n 1-bit adders with ripple carry propagation. See, so it requires lots of gates. So even some polynomial in n, if we restrict ourselves of 2 layers, so I cannot apply that does in DNF. What is that? Disjunctive normal form. So what's the bad news from this? The bad news is that almost all Boolean functions have a DNF formula with an exponential number of min terms, order of 2 power n. Can we follow this? If you do follow, then the execution time will go beyond. So I don't require such kind of application, my dear friend. Yes? So this is the mechanism. Now, that I always confront the working of the supervised, deep learning and the supervised deep learning as a convolutional network architecture. Right? See here, convolutional neural networks. 1988, it was a previous very old work, and people applied handwriting recognition and face recognition and pose estimation. Started in 1994 with the help of image, but concluded in May 2007. Category level object recognition with invariance of pose and lighting. See, it went on. And autonomous robot driving, see, went on. Supervised deep learning mechanism part has been applied. So here, the thing is that the functionality of the mechanism in terms of convex. So whether the functionality will become convex or non-convex. So the law of surface is non-convex. Ill condition has saddle points, has flat spots. Means larger networks, it will become more horrible for you, not really or actually. Okay, you try to minimize. So for reasons that are not well understood theoretically, so backprop works well really when they are highly structured with some within the fictitious environment. I can simply call that is convolution networks. So that's why supervised learning, deep supervised learning has been treated as a hard entity structure. See, simple cells, as I told you that I want to frame multiple convolutions, right? See, these are the simple cells. Now again, I'm attaching with the complex cells where a strategy has been applied. That strategy is very complex to understand, but it will resolve. Okay, and these are the part of this, so that's why these maps are considered as retinotopic feature maps. Okay, so this is the structure. Now you tell me that what kind of modality and structure and logic that you are going to deploy. It's old local shift invariance. See now, just in order to locate the number 3, see I have various patterns. Now you can ask me that I may follow style 1, I may follow style 2, I may follow style 3, I may follow style 4. I have n number of options. See, the question from this is that how do we find the filters? Guys, you tell me the answers. Answers are not answers. We have more than one answer for this. If I keep face here, then can you identify Ramesh Hanandan from this? Why? Because the pose, the fixture, everything has been changed. See, people applied neo-cognition concept, convolution net complex, fragment hierarchy concept, different type of concepts have been applied to make this classification strategy more and suitable, more and standardized. Yes, guys. Hope you understood the theme of deep learning now. Yeah, moving towards. So getting inspiration from biology, convolution network is a must nowadays. So before going to process it, please work with hands-on structure. Why the multi-layer mechanism is embedded? Hierarchical. So why? Because each and every time we are going to add the features, we are going to take the features. So testing the features within the one range of layer is not possible. So features get progressively more global invariant, and numerous. Because of that reason, we require multi-layers. This is the answer. If someone will ask you why convolutional neural network has multiple layers, multi-layers. So why? Because in order to represent the features globally, invariantly, and numerously, then we must and should get. And why these dense features are happening? Features detectors applied everywhere. That's why. And what is the mechanism of badly tuned features? So it's because of applied sigmoid units, sigmoid functions on half time. Okay. And what about global discriminative training? Those the whole system is trained end to end. Basically, that is the nature of CNN. So with a gradient based method, you must study, right, to minimize the global loss function as well. This is very much important. Everywhere you go, and even if you apply a simple functionality, you try to minimize the global loss function always. So finally, this concept integrates segmentation, feature extraction, and invariant classification in one fell swoop. Yes? Yeah. So moving towards, then this is the mathematical modeling or notation, I can say. The first one with input is 32 by 32. Layer 1, I'm taking 6 instances like 28 by 28. Layer 2, 6 with 14 by 14. See, layer 3, 12, 10 by 10. Layer 4, 12, 5 by 5. Like this. What's happening here, guys? See, 5 by 5 convolutional, 2 by 2 pooling, 5 by 2 convolutional, 2 by 2 pooling, subsampling. So let me consider 4 lakh synapses. Net for handwriting recognition. Now, how can I consider simple cells? That is called convolutional layers. So all units in a feature plane share the same weights, but we need to test. And accordingly, the sampling layer, complex cells mechanism for invariance to small distortions. It is all. And here you may apply supervised gradient descent learning algorithm using back propagation strategy. This is very, very much famous, and it is intelligently defined. If someone will ask you that how basically the concept of gradient descent works and back propagation works, now the tending strategy come in picture when we club together, right? So that's why with the help of this mechanism, we'll be able to train the entire network end to end. All the layers are trained simultaneously now. So this is your one deep learning that is called convolutional net architecture. Consider. You have different type of functionalities can be applied based on the problem you consider. Okay, now see, I want to minimize the gradient descent functionality. Why? Because loss I want to minimize. So I'm applying derivative functionality until we reach the first module. So we know that E by Wi must be recognized. So simple reason, energy function you apply, whatever you do. So this is a layer, deep supervised gradient based learning. So means, see, without understanding this, without solving this, without putting the effort, you are simply dragging the library of that, then what you will understand? Tell me now. Then how can you train your student? Or how can you educate your student? The student will follow the same concept that you did. No, this is not at all good. Okay, so fundamental mechanism must be adopted, right? So this is the one. And any architecture, now we can say why this architecture has been represented like this. No, you can have your own architecture deployment. See, this is randomly placed. One layer here, another layer here, another layer here, and that I'm making the connections among. This is my structure. But in order to defend this, I have a strong logic from my side. Why the connections have been made like this and why the layers have been arranged like this. So any connection is permissible if you have strong logic. So networks with loops must be unfolded in time. And any model is also permissible to add and delete. As long as it is continuous and differentiable almost everywhere with respect to the parameters and with respect to the non-terminal inputs, that you can do, guys. Okay, so this way we can familiarize. Now you can go beyond again. As I told you last time, then the deep supervised learning is hard to learn. So if I follow the mechanism of LSTM and others, adjusting turn H function will take at least 15 to 20 days. I had bitter experience. I thought that I can solve this problem easily, but no, it was not done. When the representation happened in terms of visualization, it was not happening properly. Why? Because I was changing the modality of neural net each and every time by changing the quadratic functionality, and the cost started increasing. So I stopped supervised learning mechanism. See, simple example I'm placing here. Why? Because identity function that which I fix with the linearity, threshold mechanism in between the range of minus 0.5 to 0.5 or even minus 0.5 to minus 0.5 like this. So that's why it is not preferable. So be careful. Now you see here. So phase detection example, if you consider, say training 52, 850, 32 by 32 gray level images of phases and 52,850 non-phases. Here, each and every individual sample, each I am speaking, used 5 times with random variation in a scale, in plane rotation, brightness, and contrast time. Now, the second, false positives of the initial version of the detector. See, the input size of the image is 32 by 32. How many features? How many maps? So, how are we attaching this? So, that is completely based on the intelligence that you. Your pen on the paper, then only it can be, otherwise no. So this is the second example that I can provide, right? So then this is the reality one. So we are simply just recognizing the pixels and mode of location, but how to convert this in terms of convolution parts? Very difficult. Every human being is having one nose, two eyes, mostly one mouth, 2 ears, one forehead, like this. Yes or no? Now you tell me. Very difficult, right? So there your intelligence play critical role in terms of feeding suitable required knowledge to the machine. So there the concept of artificial intelligence a specific problem. Okay, guys. So hopefully that I'm running with time managed in a suitable way. Still, we have plenty of things to discuss, but it is better to stop. See, phase detection and post estimation results. Yeah, can we do this easily? What is left with? So just by seeing, you cannot understand everything or anything until and unless you familiarize with the practice of doing hands-on. Okay, so these are some estimation results up to some extent. See, phase detection with a convolution net. Now let me increase my problem statement now. See here, can you do it? Person 1 is existing position 4, right side of person 5, like this. So what I mean to say is that insight, deep insight or deep insight and intuition is required to solve deep learning related problem. Now, if you do so, you'll be able to provide the solution for any application easily. Okay, so fine, guys, that hopefully you understood the theme of our discussion today. So with this, just I'm closing my point of speaking. Now we are open for asking the questions and just for kind of gathering, I would rather say. Yeah, so let me stop sharing the thing, guys. Yeah, so hopefully I'm visible to you guys. Yeah, thank you very much for the organizers. Yeah, so Yeah, tell me now. Any questions from your end specifically? And as you know that my profile is publicly available, then if you feel a little bit difficulty, realistic way that you are solving your problem with clear knowledge and the suitable knowledge, and still you are facing any problem, then do let me know. Then I'll try my level best to help. Okay. So any questions from your end? Just let's have a small interaction or a kind of interaction so that we can know each other to some extent. Yeah.
Participant, do you have any questions? Please ask. Sir is available. Dear participants, you can share your questions through the chat box also.
No issues, or you can write it to me. Then, if possible, just me write. Yeah, my email ID. Then, no, this channel can't chat is not available for me. So I request.
Sir, I will ask the questions, sir. They will write in the chat box. Those questions I will read, sir. Please.
So no issues.
Any participants having doubts, or else you raise your hands, we will enable your mic. Dear professors, please, we are ready to accept your questions. Do you have any questions? Please ask.
If not, this is fine. Then you don't need to feel shy, and hopefully, that you understood the theme of our discussion today. The main thing is like that without knowing anything practically, please don't expose yourself towards any research compilation. So this is my sincere advice, my dear friends. Okay, so then only you can enrich. Otherwise, no, you will become a normal entity of recognition. So if you want to become a pure entity of recognition, then you must and should do something at your end in terms of your own creation. Then only you will be recognized in the society. Okay. Yeah.
That's nice advice from the sir. Still, any other questions, please? Sir is waiting. If you don't have any questions, please, we'll wind up the session.
Yeah. Yeah. Okay,
Final
guys.
call for the questions. Okay, sir. Ramesh, sir. So they are having they don't have any questions. So we will wind up the session, sir.
Yeah.
Thank you so much, sir, for accepting our invitation and giving this insightful speech and presentation, knowledgeable session. Thank you so much for that. And thank you, sir. Thank you so much for the knowledgeable presentation. Your presentation was both insightful and engaging and truly enriched the knowledge of everyone who have participated. We look forward to having more such sessions with you, sir, in the future.
Yeah, it's okay. Thank you, Dr. Kiran,
you,
for
sir.
inviting me. Yeah, and
Yes,
to share my knowledge with you. Okay, guys, then hopefully that you guys have enjoyed my lecture. Then if time permits, we'll meet once again in the same platform. Yeah.
Yes, sir. Yes, sir.
Yeah. Okay, then.
Thank you so much.
Thank you. Hare Krishna.
Thank you, sir.
Thank you.
Thank you so much. Participants will meet the afternoon session at 2 p.m. And we share the feedback form through the chat box link, and we share it in the group. To fill the feedback form immediately, the form will be enabled up to 1 o'clock, and we'll meet the afternoon session at 2 p.m. Thank you all.